podcast. Here we're on journal page 53, modeling with quadratic functions. A linear function is a straight line. A quadratic function is a parabola, and an exponential function is a curve that approaches a horizontal asymptote in one direction and curves upward to infinity in the other direction. All right, let's take a look at the first example. All right. Determine the function if the function represents a table is quadratic by finding the second difference. So let's use our calculator. All right, so we're going to do 11 minus 2, which is 9. 26 minus 11, which is 15. 47 minus 26, which is 21. 74 minus 47 is 27. And 107 minus 74 is 33. So the first difference is you add 9, 15, 21, 27, 33. Now the second difference, to get from 9 to 15, you add 6. From 15 to 21, you add 6. From 21 to 27, you add 6. And from 27 to 33, you add 6. Since the second difference is all the same, this is a quadratic function. Let's take a look at the next example. All right. Determine if the function represents a table as quadratic by finding the second difference. To get from 5 to 9, that's plus 4. From 9 to 13, that's plus 4. From 13 to 17 is plus 4. From 17 to 21, that's plus 4. From 21 to 25, that's plus 4. So, since the first difference is the same and not the second, the first function is not quadratic. It is a linear function. All right, let's take a look at the next example. All right, use a graphing calculator to find a quadratic model for the given data. Enter A, B, and C round to 4 significant digits. Okay, so let's go ahead and use a calculator. All right, so we're going to go to on, new document, no. We're going to go to add list and spreadsheets, X, Y, and let's fill in the table. All right, so now we're going to do Control Doc number 5. You're going to press Tab X, Tab Y, Menu, Analyze, Regression, Show Quadratic. Okay. So your equation is 1.189x squared plus a negative 3.132 plus 6.335. Now you'll notice it says 4 significant integers. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. All right, let's take a look at the next example. All right, use a graphing calculator to find. Now, again, it tells you exactly which model you want, quadratic model. Okay, so let's go back to our calculator. Always start a new document. No. Add list and spreadsheets. X, Y. Always make sure you got the numbers in correctly. All right, now let's put in the y values. All right, now this mistake is a common. Notice how the numbers don't line up. So if that happens, you want to go back and double check your table. So let's do that, okay? So 4.7 is correct, 6.7, 8.5, 10.1, 12.8, 14.3, 15.9. Okay, so that's correct. Now let's look here. Now what happens is, like I did, is I forgot a number. So you want to see what happened there and which number it was. So 37, 22, negative 22, negative 189. And you can see here, negative 188, negative 316, negative 494. Now you can see that the table matches up. So now we can do the control doc number 5, tab X, tab Y, menu, analyze, regression, show quadratic, and there's your equation. All right, there you go. All right, let's take a look at the next example. All right, use a graphing calculator to perform a quadratic. They tell you exactly which regression, quadratic regression, on the given data. Then solve the problem and identify and interpret the domain or range of the function. The revenue of a company based on the price of its product is in the table below. How much does the company sell to maximize revenue? Okay, so first we need to do the regression. So we're going to go back to calculator. Always start a new document. No. Add list and spreadsheets. X, Y. Now you can put 1.00, but it's just going to go to 1. So you can ignore the zeros after the decimal. All right, now let's go to here. All right, so now you'll see, again, the numbers all match up, so we're good. We're going to do control doc number 5, tab X, tab Y, menu, analyze, regression, show quadratic. So the equation is y is approximately negative 18.43 x squared plus 191.4 x plus a negative 85.36. Now, to find the maximum, what we're going to do is we're going to do control doc add graph, and we're going to graph that equation. So negative 18.43 x squared plus 191.4 x minus 85.36. Now we don't see the graph, so we're going to go to menu, window zoom, zoom fit. Now we can see the maximum right there, so we're going to go to menu, analyze, maximum, click, drag, and there you go. So if the company sells a product for $5.19, they will maximize their revenue. So to model the selling price and revenue, so the domain will be x greater than 0, and the range will be from 0 to 411.57. Okay, let's take a look at the next example. All right. A trebuchet is a catapult that was used in the Middle Ages to hurl projectiles during a siege. It is now used in various regions of the United States to throw pumpkins. Teams build trebuchets to compete to see who can throw a pumpkin the farthest on the practice field. One team has measured the height of their pumpkin after it launched at 1 second intervals. The results are displayed in the table below. So we're going to go always new document, no, at list and spreadsheets, X, Y. Okay. All right. We're going to do Control Doc number 5, Tab X, Tab Y, Menu, Analyze, Regression, Show Quadratic. So there's our equation. So y equals negative 17.36 x squared plus 182.9 x plus a negative 15.45. Now to find the r squared value, we're going to go back to our table and let's move our cursor to C1 and we're going to go to Menu, Statistics, Stat Calculations, Quadratic Regression, X, Y, enter once, twice, and then we're going to go down to the r squared value. All right. Now to find the flight time, we need to go back to our graph and we're going to need to graph this. So Control Doc, add graph. So negative 17.36 x squared plus 182.9 x minus 15.45. We're going to go to Menu, Window Zoom, Zoom Fit. We're going to move the graph over just a hair, and we want to find that point right there. So we're going to go to Menu, Analyze Graph. We want to find 0, so click, drag, and you can see that it was in the air for 10.5 seconds. Okay, so the flight time of the pumpkin is 10.45 seconds. If the pumpkin travels horizontally at a speed of 120 feet per second, how far does it travel horizontally before it hits the ground? Enter your answer, round your answer to the nearest hundredths. Okay, so we're going to go to our calculator and we're going to multiply 10.45 times 120. Okay. Now, at the official competition, the trebuchet is situated on a slight rise of 10 feet above the targeting area. How far will the pumpkin travel in the competition, assuming the height relative to the base of the trebuchet is modeled by the same function? It moves with the same horizontal speed. Add 10 to the regression function, find the 0 of the new function to find the time, and then multiply by the horizontal speed. And you'll find when you do this, the new 0 is 10.51 seconds after launch. So the pumpkin will travel 1,261.2 feet. All right? Go ahead and finish up and start working on your assignment and have a wonderful Wildcat day.